Assalamu alaikum. This is Dr. Usman Sadiq Paracha, and today we would be having our lecture number 29 of the subject Applied Quantitative Analysis and Practices. So previously we were having a discussion on regression. Specifically we were focused on multiple regression and the methods which are followed, because multiple regression has got numerous methods within which we can pursue our analysis. So previously we just had a go through on the three primary methods. First was hierarchical, the second was forced entry method, and then we had a discussion on stepwise method. Then along with these methods discussion, again this is not a kind of an ideal method, so it has got its problems and discrepancies as well. So we had a discussion on those problems here, and then we had a brief overview of what is meant by R and R square. And then what do we mean by beta values here? Though interpretation of many concepts in multiple regression is round about the same as that of linear simple regression, but only the difference is regarding methods, because as we have discussed before, that multiple regression involves more than one variable. So when more than one variable is involved in this regression analysis, then the nature of the problems and the nature of the requirements of that analysis also changes. When multiple variables are involved, then there is a question of which variable should be included first, which should be included later, or whether we should put all the variables in one go in the equation. So there are numerous issues which arise due to the different nature of multiple regression, and that is why their interpretation of adjusted R square and beta values sometimes is different from simple linear regression. However, the main concept is the same, which entails that R square and adjusted R square are giving the same kind of values, the same kind of concept which we have been discussing before. However, we have to look at the significance level more diligently, specifically in multiple regression here, because the nature of these variables impacts the interpretation of multiple regression a lot. So coming to the recap of all these concepts which we discussed before, again, as we discussed before, basically there are three basic tasks which need to be followed. First is that you have to select a method, and then the second most important thing is that you have to determine the level of significance. As we have discussed earlier, that level of significance also determines that how much effective or R square would be in this case. So the level of significance does have impact on this model. Then we also have to find out any outliers or undue influence of these influential observations on the data. So based on that, then we have to go ahead with this regression phenomena. Then we had a discussion on the various methods of regression here. We have discussed before what do we mean by hierarchical, and in this we know that the user has to decide the order in which the variables are to be entered into the model. Then in forced entry we are already discussing whether all the predictors are to be entered simultaneously. So or not, then we have a case regarding stepwise, and in which we are more involving the phenomena of semi-partial correlation. And though all of these methods have got their own advantages and disadvantages, so we will just go through them briefly. Again, here in hierarchical, basically in this kind of methods, first those predictors are entered whose proof or evidence is there in past literature, and they have been tested before in this model. Then new predictors are entered into the separate block. So here basically the user has got the decision making power, which variable it has to enter and which it cannot enter, or which it would not like to enter. So here you have got the choice, which is kind of feasible, because sometimes theoretical perspective demands different kind of variables to be inculcated first, and the other types as second. So here basically the researcher has got leverage. Then again, in order to test the theory, it's considered to be the best method, because as you know that you have got the leverage to change the order of variable according to the theory. So you have got all the controls, and you can basically change the theoretical perspective along with the statistical perspective as well. Depends upon the requirement which you have in mind. So then again here basically the known predictors are then held constant in the model, and then we can predict the unique prediction of the new variable here. So this is an advantage here which you have got in performing this kind of regression analysis. But again it's also a disadvantage as well, because the total reliance is on the user, and the user can go wrong as well. So there's an equal chance of having a negative error in this case, so which is not desirable. So then we have got another method which we discussed, and it's like termed as forced entry regression. Here in this case all variables are entered into the model simultaneously, and again this is very important that we should only pursue this method when we have got very strong theoretical reasons to do so, because when you are inducting variables at one go, then there is a very high chance that these variables, their intercorrelation with each other can impact our results as well. So this basically then can have a negative impact on our findings. So based on this thing, forced entry regression basically is though it is an effective method, but then theoretical justification is necessary. Plus we also have to have an overview of the multicollinearity issue in this case. Then we had a discussion on the stepwise regression, and what is stepwise regression, and in this case again the selection of variable to be inducted is made by the software, and here basically the first variable to be inducted is the one which has got the most strongest correlation with the dependent variable. So that's why in this case the user does not have got doesn't have any control in the whole process. So this is also a disadvantage as well, because sometimes the software makes very big decisions on based on very slight differences in the variables. So this can create a problem in our analysis perspective. So then we have got the second step, in which first step we already have discussed that first variable is inducted based on the total correlation, and SPSS tries to assess which variable has got most strongest correlation here. In second step, then we are basically trying to choose, or in fact the SPSS is trying to choose the remaining predictors, and in this case the criteria used to select the rest of the variable is based on semi-partial correlation. Now, as we have discussed before, that semi-partial correlation basically is a subtype of a partial correlation. In partial correlation, basically we have discussed the phenomena here, that this semi-partial correlation basically is the measurement of relationship between two variables while we are trying to control the effect for a third variable which has influence on both. So we discussed this in this diagram which you can see here, and this concept is related to partial correlation. We have also covered this before. Then in semi-partial correlation, basically we try to control the effect of the third variable on only one of the variables here, which is clearly depicted here in this diagram. So once we have, this is the main concept in semi-partial correlation, and in other words also it tries to measure the unique contribution of that predictor to explain the variance of the outcome. So it controls the impact of any other predictors in the model. So basically while assessing this unique contribution, the next second or third variables and so on are evaluated and then decided that which variable basically is to be inducted after the first variable. So basically again there are issues with the stepwise method as we have discussed, and they are that as it is totally dependent upon a mathematical criteria, and again SPSS will choose based on that mathematical criteria, so very slight differences can make major theoretical issues in the whole model. So again, based on this, it is important that we should use such kind of method for exploration purpose only, and not while for testing any theory. So while keeping in view the problems there, we discussed about the concepts of R and R square, and we came to know that the concepts are around about the same in multiple regression as well. So we know that R is the correlation, and then R square basically gives us the proportion of variance accounted by the model. And then adjusted R square issue, when adjusted R square issue value becomes of major importance, specifically in multiple regression, because we are dealing with multiple variables, and as there is an anomaly in calculation of R square, that if the number of variables increase, then the R square also have the tendency to increase due to that increase in variables. So in order to counter for that kind of error, we have to calculate this adjusted R square, and it reduces the R square by taking into account certain factors like sample size and number of independent variables in regression. So again, based on that, another important test which is conducted to test the whole model and give us the idea about that is F-test, and here we can clearly see that it gives us the more better explanation of SSR, like regress sum of squares, and then SSE, which is basically the sum of squares for error. So then basically based on that, again we can then basically state based on that F-test that whether this model is suitable or not, whether it's feasible or not, and also the significance value for this F-test tells us whether the same results would be reported if we take another sample from the same population. So again, this F-test basically is an important measure when we are going through our assessment for the whole model, And then again we have the concept of beta values, and in this case we know that beta values are, their interpretation is around about the same which we did in simple linear regression, and we know that the change in outcome is associated with the unit change in the predictor. So again, standardized beta values are then used to compare the values with each other, and we had a brief discussion on that. Then we had taken an example of how to proceed with hierarchical regression, and in this case we would then we just stop short of a few explanations. So we will go through the SPSS again and have a look at the values, in this case at the main data file which we used for SPSS. And this data file basically comprises of 3 fields we have discussed before, and in which company boss wants to predict the sales of song albums. And in this case, the independent variables which can be termed as predictors are the number of advertisements, and then airplay, and then there is brand attractiveness also. So based on that, we have to basically test the impact of these predictors on this album sales. So we went to analyze, and then we clicked on regression, we clicked on linear here, as we wanted to take dependent variable as album sales, so we clicked on that. As advertising budget was placed first, and then in the second block, as we have discussed earlier, we selected number of plays and brand attractiveness. Then again we have got statistics, in which we wanted to choose the relevant statistics which can be which should be in fact used and measured. So in this case we clicked on R-squared chain, descriptives, collinearity diagnostics, and part and partial correlation. Then there is confidence interval, then Durbin-Watson, and then again we discussed that standardized residuals gives us a very detailed diagnostic of each case, and it tells us that whether these outliers have an impact on the mean equation. So outliers greater than 2 standard deviations are of worry, so we click on case-wise diagnostics, and then we click on 2 standard deviations which need to be the standard criteria here. So we click on continue, and then we click on plots, and as we have discussed before, that in order to get the standardized residual plots, we have to plot z values for predicted values, and then z values for residuals and x-axis. We can have additional scatter plots if we click on next, and here then we can add up more, but it depends upon what kind of residual analysis is required by the user. So we click on previous here. So we click on produce all partial plots, in which all the independent variables are tested separately with the residuals, so that we can have a detailed overview of individual variables' impact on residual analysis, so that we can also check for the assumptions for multiple regression. Then we click on histogram and normal probability plotting in order to check for the linearity and normality of the condition of the regression. So we click on continue here, and then we click on save, and here we have got a number of values which are calculated to identify the outliers in this regression. So we will discuss these in detail, and then we will generate the results again, so that we have a clear picture of what these values play in this case. So we click on options here. Again, in this case we have discussed the probability of f, which is already set at 0.05, and then we can manually change the f value, but normally f value of 0.05 is used here, and then necessarily we can include the constant in equation, and it is advisable that such a constant is included. We click on continue, and then we click on OK. So then we have got the result displayed in the output window, and here we will discuss the results. So having a look at the results here, you can very much see that these regression statistics, in which first descriptive statistics are basically displayed, and in this case album sales, and the advertising budget, and number of plays on radio or airplay, all these statistics are discussed here, their mean, their standard deviation and n values, and likewise we are also given the correlation coefficients for these. In this you can clearly see that airplay has got the strongest correlation with album sales. Next in number in this case is 0.578. If we look at the significance reported for these correlations, it is pretty much evident that all of these values are quite significant. Then we are also displayed with the n number of cases which are valid and which have been considered for calculating the regression analysis, and in this case the total number of cases are 200. Now coming to the model and the model summary here. Here you can clearly see that in the first model the predictor is the advertising budget only, and you can clearly see that in adjusted R-square that this accounts for 33% variance in dependent variable. So in dependent variable, again like f change value and the significance value of f clearly states that this model is kind of feasible. And in the second model we have controlled for advertising budget, and we are looking for the impact of attractiveness of brand and airplays. Now based on this we can see by having a look at the R-square change that these additional variables account for additional 33% variance in the dependent variable. And again, as the f value is notable and significant, so we can say that the second model is also feasible, and there is no autocorrelation here, as the Durbin-Watson value states, as the value is near 2. So coming to the analysis of variance table, you can see that in first model the regression value mean square is quite high as compared to residual, which by default tells us that this model explains quite a lot of variance in dependent variable. And the f value is stated along with its significance. Again, this tells us about the feasibility of first model. Second model also states that the regression is quite higher than residual, so definitely R-square would also be quite notable. F value has also increased and it's significant, so this second model also is suitable for us. So coming to the details of the coefficients here, we can see that first of all in first model advertising budget beta value is discussed with the unstandardized coefficient as 0.096. If we standardize this coefficient, it reduces to 0.578. Then we have got the t value and it's significant as well. We have also got the confidence interval. Now you can see that the tolerance, which is stating as the collinearity statistics, the tolerance and variance inflation factor, we will discuss this in detail, because these are the measures for multicollinearity, whether these measures are valid or not. So coming to the second model here, in which we have controlled for the advertising budget, and now we want to have evaluation for the impact of these 2 and 3 variables here, and their unstandardized coefficients are reported. But again, as we have discussed before, that these unstandardized coefficients don't help us in comparing them with each other. So in order to compare them, we have to get these coefficients in the standardized form, and here you can clearly see that once these coefficients are standardized, then value of 0.511, 0.512 and 0.192, these are reported, and then we can clearly compare them. Again, their significance value is of interest to us, and as these p-value is significant, so we can reject our null hypothesis and accept our alternative hypothesis. And again, based on that, our collinearity statistics are also reported. They will be discussed in detail afterwards. Then we have got our collinearity diagnostics, and here you can see that certain eigenvalues are reported in column number 2. Along with the dimensions, this must be noted that in various proportions table, which is shown here, so we must keep this in mind, that these variance proportions should load on a separate dimension. So here you can see that 0.96 is loading on dimension 2, and there is no other dimension, or there is no other variable which has got variance proportion in the same dimension. So likewise 0.93, it is loading on dimension 3, and then 0.92 on dimension 4. Now in the there are no not more than one variable which has got high loading on a single dimension. So this collinearity diagnostic then gives us the idea that there is no multicollinearity here. Based on that, then we are also reported case-wise diagnostics for standardized residual, which gives us a very clear picture of the outliers which may be there. So here you can see the case numbers which are reported here, and the standardized residuals which are greater than 2. Now here, with the exception of case 169, which has got an outlier ranging to 3.01, other than that, by next residuals are kind of near 2, so they can be accepted as normal. However, case number 169 needs to be seen and evaluated separately, so that we can know the cause of this abnormal reading. Then we have got the residual statistics, their predicted value, the residual and standard predicted value, and standard residual. So these residual statistics gives us an idea of what's their minimum value, maximum value, and what's the mean. Likewise, we are also stated the standard deviation here, and also the n value. Now coming to the charts here, it is pretty much evident that the residual values, they do satisfy the normality assumption, and in this case this is pretty much evident from this PB plotting as well, in which all the residuals are plotted on the predicted model. So the observed model values are plotted on predicted value. Then we have got another scatter plot in between the standardized residuals and their predicted value. Now the nature of these values are they are spread and they don't show any pattern, so we can say that they are fulfilling the condition of homoscedasticity, and likewise they are also fulfilling the condition of equal variance and linearity purpose as well. So coming to the next one, these are partial plots which are plotted against beta values. So here you can see that there's a kind of positive relationship between advertising budget and album sales, and these plots seem to be normal too here. Then we have got another set of values in which we have to compare the airplays with album sales, and again these values are not abnormal. Then we have got a partial plot between attractiveness of brand and album sales, which is not that much showing any kind of pattern. So overall, this analysis does show us a kind of normality in the results reported, and we can say that the models considered were feasible. So basically, this whole model basically does tell us that all these three predictors which we considered through hierarchical regression do show impact on the dependent variable, and they do give us a fair idea of how we can perceive their impact. So let's have a look at the forced entry method also. If we instead of following hierarchical regression, what would be the impact of forced entry method? So we go to analyze and we click on regression and we click on linear. So we go for these two independent variables should be sent back to the main list, and in this way we are deleting block 2 and we are only relying on block 1. So here first we need to test the album sales with the advertising budget and number of plays. So we are taking only two independent variables and we are using forced entry method here. So keeping the same statistics in mind, we click on OK, and here you can see that again the descriptive statistics are displayed here, and album sales, advertising budget and number of plays are placed here, and the correlation is displayed in which we can see that number of plays and advertising budget have got high correlation. Now coming to the first model here, you can see the model summary in which all the values have been entered, and you can see that the adjusted R square here is 62%. So 62% variance is accounted for by this model. Again, F change value is also significant, and we have got Durbin-Watson value at around about 2, which negates any kind of multicollinearity or autocorrelation between these values. Then we have got basically the regression value, which is quite higher than residual, so it does show that the model is feasible, and we have got an F value with significant P, so it also shows that this model is valid. Coming to the coefficients, we can say that advertising budget has got an unstandardized beta value of 0.087, and airplay has got unstandardized value of 3.58. Again, these two values cannot be compared, so in order to know which value's impact is higher, so in order to have values which can be compared, we have got standardized coefficients, and here you can see 0.523 and 0.46. Both are significant, and then we are coming to the collinearity diagnostics. Here it is clear that the collinearity diagnostics that there is no multicollinearity. Also, then we are given the case-wise diagnostics, and from here you can see that all the diagnostics are alright with the exception of 169, which is near 3, which is quite alarming. Then coming to the residual statistics, we see the descriptives for residual statistics here, and you can clearly see that minimum maximum value, the mean value, and the standard deviation here. It is evident that histogram also shows us the signs of normality, and the PV plotting also shows that the main data set is normal and is linear as well. So coming to the scatter plot, which again shows us no pattern, which is giving us a sign that our main assumption for homoscedasticity and linearity and equal variance has been justified. Then we have got the partial regression plots, which are showing the trend based on the beta value, and it is clear that the relationship between advertising budget and album sales is quite evident from here. Coming to the next one, you can see the airplays and album sales. These regression plots also show signs of normality. So based on that, we can say that this model also shows us some significant impact of these independent variables on dependent variable. So having a detailed outlook on this model also gives us the same conclusion which we have gone through before, and it is clear that the model is beneficial, and we can consider all these independent variables. So just going through a detailed aspect analysis, how we are going to present this model basically mathematically. We go back to our slide, and here basically these are the beta values which are reported in the test which we have just conducted. You can see that the beta value here basically gives us a clear idea in this case, which we have already basically discussed before, that beta 1 here is 0.087. So interpretation of that beta 1 value is that as advertising increases by £1, then album sales would increase by 0.087 unit. Likewise, we have got another value of beta 2, which is reported to be 3.58, and so that does mean that each time when a song is played on the radio, its sales do increase by 3.589 units. So this interpretation of beta value is very important, because based on that, then you go ahead with defining the importance of each variable. Then after this, let's have a look at the model. And in this model, this is very much clear. This is our standard regression equation, and if we take x1 as the advertisements here, and if we take the number of plays as x2, so here we can deploy their relative coefficients here, which can help us in this case. So based on that, this main figure intercept is reported. The coefficient which we had already calculated is put near advertisement, and then 3.589 coefficient is placed near number of plays. So if we want to find out the sales for $1 million advertising and for 15 plays, then we can put the relevant values here and we can find out this album sales which would be there for such amount of advertising spending and the number of plays. So model construction also gives us an advantage of not only putting these beta values there, but also to find out the required dependent variable values for which we may have some initial values for the independent variable. So putting those independent variable values in the model, we can easily predict the advertising, the dependent variable case here. So it's important that the model be constructed because it has got important implication, and it also gives us the true interpretation of these values which are calculated through SPSS or any other software here. So coming to the standardized beta values, because here now we have standardized them so that we can compare these values with each other. Now you can very much see that beta 1 value is 0.523, and again the interpretation is different, because now we can say that if we increase the advertising by 1 standard deviation, then the album sales would increase by 0.523 of a standard deviation. So you must notice here now that the whole interpretation is now being done with respect to standard deviations now, as in contrast with the previous interpretation which was done in reality units of the relevant variables being considered. Then we have got the beta 2 value as 0.546, and here you can clearly see that the interpretation very clearly says that if the number of plays in radio increase by 1 standard deviation, then the sales do increase by 0.546 standard deviation. Now here basically this gives us a very clear picture. If we are measuring the values with respect to standard deviations, we can clearly see that the number of plays basically is playing a more important role as compared to the advertising, though the difference is not that much in between these two standardized values, but still we can draw upon a considerable conclusion whether which value is important and which is not. So then interpretation again in terms of standardized betas is there, because if we can say that advertising increases by this much amount, which is mentioned here, then our sale would increase by this much, and this basically is the interpretation here which has been done, and basically the amount is stated here. Again, if we increase the number of plays, then we can say that the amount of sales would increase by this much extent. So basically this is another way of getting the same result, but it depends upon the user how to interpret these beta values depending upon the requirement which is needed in this case. So this is the way how standardized betas are there. Now in this case, how to report this model, because we have basically got the relevant values here in this case. So now coming to the reporting, in this case you can see the step 1 is portrayed here. We have made separate columns for beta, which you can see here. Then we have got values for standardized standard error of beta. Then we have got standardized beta values and p-values. Now here our constant basically value is reported here, and its confidence interval is also reported here in brackets. Then we have reported the standardized error, and ultimately we are reporting the p-value for that. Likewise, advertising budget beta value is reported here with its level of confidence interval. Likewise, standard error is also reported, which is quite less. And then we are reporting the standardized beta value here along with the p-value. So this is the way how we will report the case for step 1 if we are performing hierarchical regression. And in step 2, as we discussed earlier, that our constant values are reported. Then we have got reported our advertising budget. Likewise, our confidence interval is placed in bracket. Again, the standardized error for beta is kind of low, and we have got standardized beta version, which is reported here along with the p-value. So likewise, we have just reported each value for each independent variable, as you can see here, along with their confidence intervals. Also, the standardized error is reported in beta value and p-value. Now, from these standardized values, beta values, we can then come upon a decision whether which value is important and which is not, and which value impact is greater here. Then we have reported R square for this model for step 1 here, and also delta R square, which is of major concern for us in step 2, along with their p-values. So this is the standard way to report the model in a concise and comprehensive form in order to save space, because if we are trying to report the SPSS tables as it is in on paper, then it would take a lot of space. So in order to reduce the space and report those variables which are of concern for us, this method can be used to report a standard model, and that would basically help us in basically assessing the whole result of the regression model in one glance. So basically the method through which the model is reported is important, because the more better summarized the results are, the more easier it is for the audience to understand the type of results and the impact of various variables on dependent variables. So the model reporting basically is quite important in its own perspective, and only just pasting the SPSS results in various forms in the documents is not advisable. So it is important that the model results are reported in a proper way, in a proper manner, to avoid any confusion. Then again, the major issue is that how well our model fits the data. Now basically the accuracy of the model is determined by two ways, and one, as you can see here, is the residual statistic, which we have discussed before. These are standardized residuals, and then we have to look for influential cases. Now there is another tool which is used to assess such kind of outliers or influential cases, and that tool is called Coax Distance. So let's have a look at this. As we have seen that the residuals in this case are standardized, then we can say that 95% of standardized residuals should lie between plus minus 2. Now these are the empirical rules which we already discussed before, and as the values have been standardized, then all these empirical rules can be applied on such samples. So then again 99% of standardized residuals should lie between 2.5. So basically the values which are falling beyond these values are basically of concern for us, because they can be a big problem for us. So then we have got outliers. In this case, any case for which this absolute value is of the standardized residual is 3 or more, that likely is to be outlier. Now we have already discussed this condition in empirical rules, because empirical rule clearly states that any residuals which are like in this case 6.8% values should lie between 2 standard deviation, and then again most of the values should lie within 3 standard deviations. So here, based on that, we can then detect the abnormal values in this case. Then there is a Coax distance, which basically measures the influence of a single case on the whole model. Now, in order to measure the influence of that, these certain values are calculated through certain mathematical procedure, but in a nutshell, it is important that the values which are reported for each case, and Coax distance is calculated for each separate case. Now in this case, the values which are greater than 1 would be abnormal, and that would be a cause of concern for us. So then we have to look out on generalization issue. So basically we have to basically generalize this whole sample model on the whole population. It is quite important that in order to generalize this sample model to the entire population, our assumptions are met, and without meeting these assumptions we cannot generalize that sample to the whole model. So then if these assumptions are not met, then we can say that this kind of model is only applicable in certain conditions on certain kind of samples. So there is a drawback that then that whole model cannot be generalized to any other phenomena. So that's why these assumptions must be tested for fulfilling the generalization definition. So these are the straightforward assumptions which we have discussed before, and one is the variable type. Again, it is important that your dependent variable should be continuous in nature. Again, your predictors should also be continuous or dichotomous, but in dichotomous again we have to convert the data into acceptable form, and then we can run our analysis type in there. Then we have got zero order variance. Here again, non-zero variance is important, that independent variables should not have zero variance. Then we have got a linearity, that the model we are trying to predict in reality should be linear, and we have the relevant conditions for that which can be tested so that we can know whether these conditions are satisfied. Then independence factor is important, that these values for outcome variables, all of them should come from different persons so as to avoid biasness in this case. So in order to ensure this independence, again these kind of conditions are normal to be presented, and overall these assumptions are important. We cannot ignore any one of these. Any abnormality in any of the assumption would then drive us to have a look at the data set and the nature of the values entered in that data set, and then we have to treat those values accordingly so that we can fulfill all these assumptions. Without these assumptions fulfillment, that regression result again would be limited to that specific sample. It cannot be generalized to the whole population then. Then there are more trickier assumptions which are more technically speaking more sound, and in this case one is there should be no multicollinearity. So again we have discussed that in detail, that the predictors should not be highly correlated with each other, and that is very much desirable. In order to detect that, we do use collinearity diagnostics, and there are various measures which help us in doing that. Then another trickier assumption is homoscedasticity, and in this case again the variance of the error term should remain constant all the way. Now in this case we have to look at the residual analysis and the regression plotting, which we discussed before. Then we have got an issue regarding independent errors, and these terms should not be uncorrelated. Now this is a very tricky assumption, and we have to check it out in proper means. And again, our regression plotting basically against the z values or predicted values is important, and it gives us a very good idea of what is the nature of data we are dealing with. So then we have got normal distributed error, which again is a major condition. This condition can be very much assessed through PP plotting or through a histogram of residuals, which can be developed anytime. So then after these trickier assumptions, another important issue is related to multicollinearity, because you must have noticed that many of the assumptions address this phenomena, multicollinearity issue. And multicollinearity basically only exists when your independent variables are highly correlated with each other. Then they would try to distort the results obtained from regression analysis on dependent variables. So that's why this assumption needs to be checked through collinearity diagnostics, and it helps us in determining which variable is causing that multicollinearity. Then we have got another basically result which we have displayed here, and in this case you can very much see where the collinearity statistics are displayed. And in this case you can very much see that the tolerance is shown here, VIF is always shown here. The golden rule here is that tolerance should be more than 0.2. And again, VIF is opposite to tolerance, so it should be less than 10. So based on these values, then we can assess whether the data set is multicollinear or not. And if it is, then we have to treat the data accordingly to minimize this multicollinearity issue. Then again, we have already discussed, these are the various plots used for checking these various kind of assumptions. Here in homoscedasticity and independence of errors, we can see that Z residual is plotted against Z predicted. Then in case of normality of errors, we have got normal probability plotting, which basically clearly is plotting the observed values on predicted values, and we try to check out whether we have got a normal probability plotting or not there. So going through the visual diagram, now here you can very much see that the plots have been made and displayed here, and here in this case, in case of homoscedasticity, it is pretty much evident here, and in this case this, as it is evenly spread, gives us a good idea that the condition for homoscedasticity has been met, because the residual here is basically dispersed, not making a pattern which is desirable. Likewise, we have got partial plotting for other variables displayed here as well, and which to the maximum extent are showing us that our assumptions have been justified mainly in this case. Also, in terms of normality of errors, we can see that the histogram and PB plots clearly indicate that these values are basically, the residuals are in line and aligned. They are fulfilling the requirement of normality and linearity. So based on that, the assumptions basically are finally met for the model which we are trying to state here. So in today's lecture, basically we had a discussion, and we basically applied the SPSS in order to portray some various examples, in order to explain various methods for multiple regression. Then we had the discussion on how to formulate these multiple regression equations once we have got the data from SPSS analysis. In SPSS application, we discussed in detail basically how to display the model, basically how the regression results are reported, how to interpret the main model summary, then how to interpret the ANOVA table there, and then how we can interpret the coefficients which are reported in SPSS software results window. Then we had also discussed about the various other measures like standardized residuals reporting, how to interpret those, and likewise the residual analysis, how we have to examine such kind of analysis in order to know whether the assumptions for multiple regression are met or not. So then after that we formulate the equation. We just place the values obtained from SPSS for independent and dependent variables in this multiple regression equation, and then we try to interpret them mathematically. So basically the beta values are then placed in the equation, and then we interpret what is interpretation and how, if we want to find out the value of dependent variable at specific point in time, then how these values in the equation can help us in getting these final values. So we had basically a discussion on that. Then what is the interpretation of these different beta values, why standardized beta is important, and how we have to convert these unstandardized beta values to standardized beta values, and then what is the advantage of beta values in this case. Then after going through the interpretation of these different beta values, we had a discussion on how to report this statistical model, because it's not just about copy and pasting the SPSS results in any specific document, but it's more about how to display the results in a more effective way so that we can basically quickly come to the conclusion on looking at the data that what's the impact of independent and dependent variables on each other. So the model reporting is very important, and then we had a discussion on the assumptions which we need to work out before commencing multiple regression and after when we have commenced with the multiple regression. So multiple regression results are of importance, and their assumptions, if these assumptions are not justified, then our results for multiple regression cannot be accepted. So it's important that these assumptions like homoscedasticity, independence of error, equal variance, all of these need to be justified, and again their values, regression values, should be plotted so that we can have a look at the pattern and then decide whether these assumptions have been met or not. Once these assumptions are met, then we can go ahead with the rest of the analytical part. So this was related to the regression part. I hope you understand this thing. Thank you so much. Allah Hafiz.